Okay, this is a standard motor from Techtop, and I'll point out this was used on the chicken plucker. I'll show you what happened to the motor, why I think what happened to it, what I like about it, what I don't like. Here's the nameplate. I don't think this is IE3. I think this is standard IE1. But it's got a nice big full information nameplate. Note that it's CE, CSA, UL. Bearings are 6206 shielded, front and back. Suitable for 208 volt, 60 hertz at 8.1 amp. It's got a 1.15 service factor at 60 hertz, 1.0 at 50 hertz. I guess that's because it's 230/460 instead of 480. I'm not sure. This is about what you want to have on a nameplate. The date is some kind of a code because those wouldn't work. The entire body of the motors looks like it's been polyester epoxy painted before machining. In some kind of industrial gray. We'll start with about the terminal blocks. Here's the cover. You can see that it's been staked, which keeps the gasket in place. And I don't think we leaked through the terminal box at all, not through the cover at least. Here's their 9 lug, 9 lead. All the leads are numbered. You can see the size of it, pretty good size. It's about the size of what we'd use on a 112. But the plates, I don't know what that is. It looks like just stamped steel. For the bars. Of note, it's resin filled between the terminal box and the stator, so no water is going to go from the terminal box into the stator. The electrician installed this, punched this hole and probably brought his watertight connection in. Did not seal it. You can see where water got in here and corroded, but it didn't hurt the terminal block, and none of that water would have gotten into the stator. It just corroded the screws. The moisture was in here. Kind of a typical something you'd see in the US, where the electrician drilled that out and put a nut and lock and unsealed connection. Less than ideal. Externally, you can see the grounding points. See some chicken feathers. We'll move on to the rest of the stator. Here's another grounding lug. Now, in some Techtop motors, they'll seal the covers. This one, there's no sealing here. You can see the corrosion. So water seeped in through that, undoubtedly. Yet, they tropicalized the stator as standard. Really, I'm personally not that impressed with tropicalization because, so you put a little paint on this. This is all steel. This is all corroded. It's all rusted. So putting paint on the windings, good for you. It does nothing for me. I have a stainless steel plate that shows their connection diagram. It's been riveted on. We do ours on our nameplate. Let's look at the back side. You can kind of see some of the corrosion from the light. But like I say, tropicalization does nothing for that. Big deal. Wasted money. We have moisture coming in through here. Here's the cover. On the non-drive side, some of the hardware. You can see the corrosion. So, in my opinion, the motor sat like this. My thumb is where 12 o'clock is. 6 o'clock's at the bottom. Moisture sat, and condensation sat and corroded at the aluminum. Some of the moisture that went inside. You can see the corrosion, the water that got through between the motor covers and and the stator body on the lip there. You have a seal on the back side. It's just a double lip Buna N type seal. You can see where the material collected. Unlike the American-made motor, here's our fan. So we have kind of a typical Chinese fan, which is fine. It's got 5 blades. You notice that there's a keyed on. And then there's a snap ring that retains it. Snap ring. I think we call them Seeger rings. That's what we call a snap ring. That would be here, holding it on. There's a groove cut in the shaft. As you can see, it's had its fair share of abuse, but the blades aren't broken because it's pretty strong plastic. Now, next I'm going to show, since we're on the subject, this body is all aluminum. The end covers are aluminum. It's like a copy of a Italian motor, I would say. A good copy. I mean, they did a lot of smart things. But here's the fan shroud. And there's not a lot of air moving through this because this is got the better part of a feather pillow inside the fan shroud. So cooling this motor would be difficult. It's good. Basically, it's pressed steel. It's been polyester epoxy powder painted. It's in pretty good shape considering, but there's no airflow going through that. The wave washer on this motor is on the back side, on the fan side. Here's all of our fasteners. You can see oxidation. Moisture is passing through these. But, you know, it doesn't matter here because it's got nuts. It's not going into the motor. Next we'll do the V14. There's a couple things that are interesting about this. First, it's been drilled through and tapped through, which is okay. I don't see a benefit for a standard motor, but I don't know everything. It's just that's where moisture will come through. Water will come through those holes. There's corrosion. Zoom in a little bit. There's corrosion on the covers. You can see where this one sat. This would be again, my thumb at 12 o'clock, the base at 6 o'clock. This is how this motor sat. Moisture is collected at the bottom and corroded. These front bearing is retained. It's got a washer that has screws from the front that go into the plate that's tapped in the back. Okay, they're pocketed. And then it's got a NBR double lip seal, so it's got a garter spring on the inside and a wiper lip on the out. That seal has seen some chicken feather abuse. Whatever it was connected to is made out of steel, and there's some residual rust with the aluminum oxidation combined. So it's polyester epoxy powder painted prior to machining and assembly, but it's just looks pretty. Now we'll come to the last part, the rotor itself. So as said, this has 6206 bearings, which are standard for this size motor. It's got an end milled key. It's a standard drilled and tapped in, standard to an IC motor. You can see where the seal was land riding, wearing here. Then they back that with ZZ shielded bearings. Yet they spin freely, they're fine. Here's the backing plate, but as you can see, there's no seal to this. There's no seal around it. There's no moisture protection from getting moisture from the outside of the motor into the motor. It's just a piece of steel that's been tapped, and the screws from the front hold this bearing in place. So the front bearing is fixed and the back bearing is floating. The rotor itself has had some sort of varnish applied. It does have corrosion. So it has where it's probably when it was sitting still, the moisture inside the motor corroded and stuck to the stator. This is the non-drive side. This is the fan side. You see the design is similar to a European design. This is probably the bottom. It sat here. Got oxidation. You can see where there's corrosion on the bearing, where moisture is probably at the 6 o'clock position. Here's how their fan keys into this. So it's cut with an end mill, but it's seats here, and then the snap ring goes here. That's their design. Has a snap ring groove, and then I don't think it's really tapped at the end. And you can see where the seals have run. It's pretty good shape considering, but you know, water got inside of this motor and started to corrode and rusting the rotor to the stator, and then not enough cooling because of the fan shroud's covered in feathers. I mean, feathers is more of a problem than moisture, maybe, I don't know. Between feathers and moisture, you can see the balancing of this type of motor. I don't know how the Americans are balancing their motor with the tabs, because one side didn't have anything. But so this is the techtop that failed. But this is just a standard motor. If it was purpose built, if they would have sealed the covers, done bottomed end taps and a slinger ring on the rotor, I think this motor could have saw more life for sure. But tropicalization is pointless, you know.